Hello students, welcome back. In the today's session, we will see how to find out the Z transform of an impulse and a unit step sequence. So let's start with. It should be clearly noted that while we are discussing the Z transform, it is only for the discrete time. It should be clearly put into the mind for discrete time. LTI systems. So this is one of the most important thing. That means when you are in the discrete time, your signals are not in the continuous time. They are discrete in nature. That means they appear as sequences. For example, they will appear as sequences. Let's say 0, they will appear as this sequence. The values are defined at a discrete instance of time, not everywhere in the plot. So with that background, let's move ahead. So in the day's lecture, we will take up two examples. One for the delta signal, that is the impulse, and second for the unit step sequence. So one, find the question, let me find the Z transform, Z transform of the unit impulse sequence. Unit impulse sequence. Question number 2 will take up find out Z transform of a unit step sequence. It should be very clearly noted while you are discussing a topic on the Z transform. You see the question itself. The question clearly says it is a sequence. Let me underline it. It is a sequence. And hence, we need to find out the Z transform. Let's see the solution. You know what the Z transform is. We know what x of z is equal to. This is nothing but summation of minus infinity to plus infinity of x of n into z power of minus n. And you know what this xn given, where given is x of n is nothing but a unit impulse sequence. So this is written as unit of impulse sequence. So putting this value there, and you know what the unit sequence is, it has a value 1, it is a value 1 at n is equal to 0. Elsewhere, the values are equal to 0. So this is how the signal is represented. So this is how the signal is represented at 0. So at all the other places, the value is equal to 0. So putting this value there, so you have the minus infinity to plus infinity of del of n into z power of minus n. And you know, you know what this del n from this graph, I can write down what this zn is equal to 1 for n is equal to 0 and 0 for n not equal to 0. So once this is clear, I can directly put the values over there and say my x of z will be nothing but this, which is equal to 1 itself, because the is a summation. It is a 1 plus 0 everywhere, whatever the value of n is, whether negative or the positive. So therefore, therefore, I will have the answer as equal to 1 itself. So this is my x of z. This is the part one answer. The second part is on finding out this. Then second is you need to find the ROC of it. And in the case of a impulse sequence, the ROC is very well known here itself. The ROC is 1 everywhere. That means the ROC exists everywhere in the Z plane. So as can be seen, as can be clearly seen in the equation itself. So let me write it as can be clearly seen in the equation, and let me write the equation as 1, as equation 1, that x of z is equal to 1. That is the ROC exist everywhere, exist for every value of z, for every value of z, for every value of z. So that means you can say, therefore, x of z converges. And where does it converge? The ROC is the entire z plane, entire z plane. So that means what? Okay, if I have a z, real part of the z, real part of the z, imaginary part of the z, so therefore the entire z plane is the ROC. Let's see the second one. Now for the unit step sequence, you know what the unit step sequence is? Unit step sequence is for n is equal to 0 and beyond on the positive side. For positive values of the n, the un step, now it is not ut, it is u of n. U of n is equal to 1 for n. So how do you define it? I define u of n is equal to 1 for n greater than or equal to 0 and 0 else. So this can be now put into the standard equation for the Z transform. So therefore, the solution is with this background, you know what the unit step sequence is, this. So therefore, with this background, I know the x of z is nothing but given by the summation of n is equal to minus infinity to plus infinity of x of n into z power of minus n, where your xn is the input signal which is given as a unit step. So let me mark it with a different color. So where xn is equal to unit step u of n, it is given in the question. So putting this value there, so therefore putting this value there, therefore the above equation x of z will be equal to summation. It is only the positive sided, so therefore I can put n is equal to 0 to infinity. Signal is one sided, so for xn I can write u of n into z power of minus n, and in the positive range the value is equal to 1 for the un. So therefore I don't need to write this as 1. Still, if you need to, you can do so, but let me skip that because I know un is equal to 1. So therefore this is equal to, for n is equal to 0 to infinity of z power of minus n. Now put all these values there when n is equal to 0. So you get z power of 0 is equal to 1 plus z power of 1, z power of minus 1 plus z power of minus 2 plus z power of minus 3, and it goes this way. So this means what? As it can be clearly seen that this is a GP. a geometric progression. And for this, we know the formula for the geometric progression, that is equal to a upon A is the first term. So this is the first term, and you say R is the second term. So then for this, the answer is, for which the S is equal to 1 over 1 minus R, where A is equal to 1 and R is equal to Z power of minus 1. So therefore, putting these values there, so therefore I will get the X of Z is equal to A is equal to 1 upon 1 minus R is equal to this value, that is Z power of minus 1. So this is the answer. So if you wish to further write down, so I can write Z power of minus 1 is equal to 1 by Z, taking LCM, Z minus 1 and Z will go up. So this will be Z upon Z minus 1. But this is all for finding out the first part of it. The second, you need to find out the ROC. And for ROC, I will take this particular equation. What do you say is the reason of convergence? To converge for, or let me write for xz to converge, xz to converge, for this to converge, this part Z power of minus 1 should be less than 1. So therefore 1 by Z is less than 1 or Z greater than 1. So if you put this value, so equivalently you can say 1 by Z less than 1 or Z is greater than. So therefore the ROC is for Z greater than 1. So that means if you draw the Z plane of a unit circle, for Z greater than 1, if this is Z, real part of the Z, and this is the imaginary part of the Z, for Z greater than 1, here it is representing 1. So beyond this will be the ROC. So if you say my complete plot is this, and now if you wish to write down, so if you write down this, the ROC, draw the right ROC. So ROC will be the plane for Z greater than 1. So for Z greater than 1, this will be my ROC. It should be very clearly known. Let me repeat it again. First, Z transform is for the discrete time sequences. You need to represent the sequence mathematically, as you have done in the case of a impulse, which is represented this way, and the unit step represented this way. Then put this value of the signal for xn, and now if you simplify the series will be GP or AGP, etc. And you can directly put the formula for that GP or AGP to get the final answer. And once done, the last step will be to find the ROC. And once you have found out the region of convergence, only then we will say the answer is complete. So see you with more examples in the next video.